Welcome back, guys. Let's talk about quantum mechanics today. What it is that it helps us understand how the tiniest parts of our universe like atoms and particles behave. So let's start with some key ideas. Number one is quantum uncertainty. We can't know exactly where a particle is and how fast it's moving at the same time. So looking at one changes the other. So we are unsure about that. Number two is quantum entanglement. This is when particles are connected to each other, and what happens to one it affects the other. No matter how far apart they are from each other, it affects both of them at the same time. Number three, quantum superposition. Particles can be at multiple places or states at once, and until they're observed, then they choose that state. So this is called quantum superposition. Don't worry about this if this getting confused. I have a very nice example at the end of this video to make it easier to understand. Number four, we have quantum tunneling. Particles, these can move through barriers that seem impossible. So just hear me out, keep noting these down, and let's move on. Number five is a wave-particle duality. This is like the particles are like light. They can behave both as waves and particles, and depending on how we look at them. So it's how we see them, that's how they behave. Next is observer effects. Watching a quantum particle can change how it behaves. And number seven is quantum fluctuations. These are tiny changes in energy that make particles move unpredictably. So small changes, and they might behave differently than they did previously. Number eight is quantum teleportation. This, for example, involves transferring the state of a particle to another far away without moving the particle itself. So that's that. Number nine is quantum entropy. It measures disorder in the quantum system, and the more disorder means higher the entropy. Number 10 is quantum interference. This is when particles are in a superposition. Their waves can overlap, creating different patterns. And number 11 is quantum decoherence. When a quantum system interacts with its environment, it loses its quantum properties and starts behaving more normally. Now let's make this fun so you can understand this better. Now imagine there is a magical butterfly named Glimmer, right? Just any name. I'll call her Glimmer. She lives in a quantum garden, and then this garden is so tiny that we can't see with our own eyes. And it's a place where strange but wonderful things happen. And in this quantum garden, we try to figure out exactly where Glimmer is, how far she's flying, and it's like a guessing game. This is because quantum uncertainty means we can't know both our exact position and speed at the same time. So because looking at one changes the other. So imagine special flowers in this meadow or garden, and they can communicate without making a sound. When one flower feels a tickle, the other reacts to, even if they are far apart. This is called quantum entanglement, and this is where particles share a connection. They move together no matter the distance. They have a connection between them. Glimmer flying among these colorful flowers. Sometimes it looks like she's in two places at once, and sometimes it doesn't. And this is like something called quantum superposition, where particles can be in multiple places at the same time. For example, if Glimmer is, or the butterfly named Glimmer, she can be near two different flowers at the same time. One day Glimmer finds a closed gate. Even though it seems impossible, she manages to slip through it. And this amazing trick is called quantum tunneling, where particles can move through barriers that basically seem impossible to cross. Now, moving on behind this gate, Glimmer creates a streak of beautiful colors in the sky, and much like how particles create and act like waves, it creates patterns of lights which are beautiful, and they are known as wave-particle duality. Sometimes Glimmer the butterfly, she shimmers brightly, and the other time she is just seems almost invisible, and just like that, particles can change their state. Now imagine someone watching Glimmer the butterfly dance. Her movements changes when she knows she's being watched, and this is called the observer effect, where particles behave differently when they are being observed. Now, Glimmer the butterfly's dance can be unpredictable. It can have twists, turns, and they don't follow a pattern. So this will remind us of quantum fluctuations, where particles make random movements that keeps scientists guessing all the time. They don't know exactly where it's going to move. And now, moving on, it looks like Glimmer the butterfly teleports from one flower to another in this garden, just like how particles can instantly move from one place to another. And this phenomenon is called a quantum teleportation. Now imagine a breezy morning in this quantum garden, where everything is like a delightful mess. Flowers sway in different directions, and Glimmer the butterfly's flight is more unpredictable than usual. And then this plays chaos, just like the quantum entropy, a measure of disorder in the quantum world. So as Glimmer the butterfly flutters, her wings create ripples in the air and they form beautiful patterns. And that is like the quantum interference, where particles overlap and create stunning designs. But sometimes Glimmer the butterfly's magical dance, it loses its charm. When she flies near a mysterious fog, it becomes very similar to quantum decoherence, where particles lose their special properties when they interact with the environment, and they behave differently if something happens differently in their environment. So with that, we've come to the end of our video, and that's the amazing world of quantum mechanics, now seen through the adventure of Glimmer the butterfly. Hopefully that made it easier for everyone to understand. As we know, science is full of surprises and it's waiting to be discovered. Tell me in the comments, how did you like this video? And if you have any questions, please post them below. Make sure to like and subscribe to my channel. Thank you.